Right, I'm live. Check. Yeah, yeah, yeah. All right. And 2 minutes, 3 minutes late. The stream started. The adventure code started. All right. Okay. Let's jump in. First one, December 1st. Let's try to understand what challenges and solve it. We have 1 hour time boxed, but hopefully day first be a little easier. It won't take us an actual hour. All right. Why are we doing this? Saving Christmas, probably. As usual. Chief Historian, Big Christmas, cinnamon months. Yep, see, Saving Historian for Christmas. North Pole, alright. Alright, star, yeah, 50 stars. So once you finish the whole Advent of code for this year, you get 50 stars. One puzzle grants, yeah. Each puzzle gets a star. You get 2 sub puzzles, so you get 2 stars per day. Yeah, right now you have nothing. Blah blah. All right, gonna keep it up for a little bit more. All right, here's the more interesting things for that thing. So we get not the name but location of the chief's office, right? To make sure they don't miss anything, you're going to split into 2 groups. Okay, each searching the office and trying to create their own complete list of locations. They're holding the list side by side. It becomes clear that the lists aren't very similar. They need to reconcile their lists. All right, so 3 4 4 3 2 5 1 3 3 9 3 3. All right, I don't know what this is yet. All right. Still don't know. That's okay. Oh, I forgot to put some music on. Let's do some music. Too loud. There you go. Yeah. Still too loud. Yeah. All right. Pair the smallest number in the left list with the smallest number on the right list. Second smallest on the left, the second smallest on the right. Okay, so in this case, this is the smallest one right here, and the next and the smallest one. Oh, there's 2 3s here, so which one is the smallest? Okay, within each group, figure out how far apart the 2 numbers are, and you need to add up the distance in rows, I guess. If you pair up a 3 from the left list, okay, which one? With the 7 on the with the 7 from the right list. There's no 7. Okay. The distance is 4. If you pair up 9 and 3, the difference is 6. Yeah, that's the difference. In the example list above, yeah, the smallest number on the left is 1, and the smallest number on the right is 3. The distance between them is 2. Okay. The second smallest number on the left is 2, and the second smallest number on the right is 3. Okay, so they're treating, yeah, okay. But there's 2 3s here. Smallest number on the right is 3. The distance between them is 2. 2 1 or 1. Okay, they're being coy. Oh, I guess it's the first one. Alright. Third smallest is 3, the distance between them is... yeah. 1, 2, 3... No, wait, what? Oh, it doesn't matter. No, the distance is... Oh my goodness, yeah. That's the distance. I thought, I mean, the distance they meant is in terms of rows distance, but it's how much 3 is bigger than the 4 or whatever. Okay. Total distance is okay, and the actual left and right locations, blah, blah, blah. What is the total distance? All right. So, here's what I like to do. I had a script to do this, actually, but I didn't get to do that. So, here's show you what I do. Step 1, I create a new file here. I call it o1e txt. E is for example, and again I have a script that does this. Then there's a puzzle input, that's my input. There's gonna be o1 txt. Still not fully awake. Oh well. And then in boom, and then in O1 I start solving it. O1 APL, because we're solving it in APL. It's the best way to save center. Step 1, we need to read. That is the function, or whatever it's called, in APL. O1e txt, and you need to pass 1 as well, and that will give you a bunch of stuff, and you want the first thing because that's the body. All right. Now it doesn't look like much. That's okay. That's actually if we turn into a matrix, right? Into an array of arrays. But we really need to evaluate each row. So we get now the numbers, right? And in APL, we can reshape it like this, turn it into 2 rows, and then if I split it, I get, well, I have 2 arrays. That'll be A and B, right? We'll call it A and B. Then we sort, print again A, right? But we need to sort it, so we want to have the increasing order, except of course this prints it in a hold up, shape. So this is a function that takes an argument, sorts it, but it returns indices of the sorted array, and then we take the indices, map them to the actual values, and this is the numbers. And we want to do it for each of A and B, and we get sorted arrays. So that's how you sort them, 2 arrays in one. And then, because these are 2 arrays, we can do the difference between them. Now we don't care about the absolute values, or we care only about absolute values. 210, 125. Let's double check. And 210, 125. You can't see it because I'm only sharing, but it doesn't matter. That you can trust me. That was the right answer. And then if we sum it all up, we get to just turn into simple array, and we get 11. All right. Okay. So now we run this for real value, and let me switch to Chrome, paste the value. Hopefully this is correct. Yay, we got the first star. All right, so far so good. Your analysis is confirmed. Okay, part 2 now. To agree which made a mistake or how to, okay, blah blah blah. So they made a mistake. This time you need to figure out exactly how often each number from the left list appears in the right list. Oh, okay. All right. So this is an example now. That's the same one, I think. Yeah. So the first number in the left list is 3. It appears in the right list 3 times. So the similarity score is 3 times 3 is 9. Okay. The second number in the left list is 4. It appears in the right list once. Okay. That's it? Okay. Yeah. So 3, 3, 4, 1. 2 appears in the second list 0 times, so 2 times 0. All right, now imagine. Okay, but what about repeated numbers? The fifth number 3 appears in the right list also 3 times. Yeah, so 9. So there's a bunch of 9s every time there's a 3 on the left list. All right, and we sum it all up. Okay, so how can we do that in APL? Probably you think hash tables and stuff. No way, Jose. Don't even have that functionality. So first thing first, we'll look at list A. Let me switch back to example input. We can hide the first one because it doesn't matter right now. And then we do a, for each one, let's say we have a 3. If we can check if it exists in B. Equal? Yeah. This will tell us if it exists in the second list, and we see that it exists in 3 locations where it's marked as 1, right? Because B is, we have 3, 3, and 3 here. Let me just double check that I'm showing the right screen. Yes, perfect. Yeah. So 3 equal B, but we need to do it for each one of items in the A. So we can't really do this. That doesn't make sense. We can do an outer product. So this will do an outer product. Yep. Of all things in A equaling all the things in B. And if we sum it all up, and let me check which one that is. Yeah, it's the just compresses it into a list of just a list of sums of how many there are. So we have 3010033, 30310033. Yep, then it checks out, and then we just simply multiply by A because that's what they wanted. So we need to have a bunch of 9s and a bunch of 0s, and then we sum it all up, and the number is 31, and that's correct. That's what it was for example input. I think that's it. So now we need to solve it from my input so I can submit it. That's the answer I get, and switching to Chrome, solved, done. 16 minutes. There you go. Now let's see how well other people did. First day, people's 9 seconds. All right, we have 9 seconds. We have 54 seconds. I mean, 9 seconds. But I think last year I saw some crazy things like that. No, surprisingly. Anyway, 9 seconds is crazy. I imagine that's for both stars, right? Yeah. All right. Yeah, there you go. People solve it pretty fast. Next one is next puzzleism. 23 hours, 42 minutes. It's gonna be fun. First one was pretty easy for APL, and I'll see you tomorrow. Bye all. Have a good day. Bye all.